So the manual testing, so we are going to learn different concepts. So let me list out what are the concepts we are going to learn. So as part of manual testing, so first thing is we are going to learn about testing concepts. Testing concepts. So this is the first initially. So in the testing concepts, we are going to learn about what is testing, what is quality, what are the different types of testings, or functional testings, non-functional testings, or levels of testing. So what are the different models available? So these are all comes under the testing concepts. So that's the first phase. So once we have understood the testing concepts, these are all completely theoretical. Okay. So once we understood the testing concepts, then we will move on to the testing process. Testing process. So here we are going to learn about how exactly the testing process will start, how it will going to be happen, and what are the different activities we are going to perform as part of the testing process. Like in this phase, we are going to discuss about how to prepare, how to understand the requirement document, on how to write the test plan document, how to write the test scenarios and test cases, how we can execute them against the build, and then how we can report the defects. So all these things we are going to learn about testing process. So that's the second phase. And then we are going to discuss about agile process. So currently the market trend is following the agile process. So what is agile process? How the activities are going on as part of agile process, and then continuous integration process. So all these things will be discussed as per this particular phase. Continuous integration, and then right. So and then we will see after completion of this, we will see about it will take a small project or mini kind of project, and then we'll understand the requirement document, and then we will prepare our test cases. Okay, all kind of activities like let's prepare or let's understand the document, and then we prepare the test cases, and let us find out what are the defects we have. So all these things we are doing as part of this particular project. So this is about the manual testing. Okay. So now let us focus today on testing concepts. Let us start with the testing concepts. These are completely theory process. This is completely theory, and this is again theory plus practical, right? So now this is again theory, and the last one is purely practical session. Okay, so this is the plan as part of the manual testing. Once we finish this, then we go for the SQL plus database testing. Now let us start with the testing concept for today. So let me share my presentation. Just a second. So in the testing process, we are going to learn about, first let us start with the what is software. So what is software? So software is a collection of programs that help us to perform a certain task. So what is software basically? A software is a collection of programs. So who will develop those programs? So the developer will develop the programs. Why they develop the programs? Because to achieve certain tasks. Suppose for example, if I take any banking kind of application. So this is some banking kind of application. So what is the use of this banking application? The customer will interact with this application and they do certain kind of transactions. So that is the user point of view, that is the main usage. So how they develop this particular software? There are n number of people who are involved during development process. So like managers or product managers or developers and then testers, release management team. So there are n number of teams are involved during software development process, right? So each individual having their own roles and responsibilities. So why software? The software is a collection of programs. So developer writes certain programs by using any programming language like Java or .NET, C Sharp or whatever. So they use any kind of programming language and then they develop the small programs. And then they will integrate all these things and they make it as a software. A software is a collection of application or computer programs that help us to perform a certain task. So as a user, we will see only the UI part. Whatever transactions we are doing, that we can see. But how they are happening internally. Suppose if I enter some details here, when I click on the submit button, these details are going and storing in the database. How it is happening. So the developer retains certain code inside. The code or program will take care of this. It will take the particular details and send them into database. So internally, the user interface and the backend, there are certain programs keep on running. So those programs are developed by the developer, but we cannot see those programs. Why? Because this is completely sensitive and they have restricted the access level. So we can see only the application. So this is completely black box. And internally whatever code they have created, that is comes under the white box. But that we can see programs. But here as a user point of view, we cannot see anything. Just we can utilize it or we can use to perform certain tasks or operations in the front end application. Okay, that is basically software. Now if we come to the softwares, there are three types of softwares in the market. So we can call as a system software, programming software or application software. System software, programming software and application software. So these are the three types of softwares. System software is nothing but like device drivers, operating system, servers, utilities. These are all comes under system softwares. So for example, operating system. So if you want to work with the computer, you require operating system, either Windows or Linux or Linux, whatever. Without operating system, we cannot even boot the system, right? Operating system is compulsory there. So once you have operating system, then you can install other softwares. So those operating systems comes under system software. So those softwares are used for running your systems or computers. So there comes under the system softwares. And servers and device drivers. Device drivers means, for example, if you're connecting some device to your laptop or USB cable or keyboard or mouse or hard drive. So if you want to work with those drivers, if you want to work with those devices, certain drivers should be there in your system. Suppose if you are connecting external hard disk, immediately it will start installing some driver. Similarly, if you connect your mobile phone to your system, it will start installing some drivers, right? So those drivers are comes under the system software. So device drivers, operating system, some servers or some utilities. So these are all comes under the system software. System software. So those softwares are used for running your systems basically. And then programming softwares. So programming softwares are used basically for compiling or debugging or interpreting your programs. Suppose in Java or C or C++ or .NET you have created some program. So if you want to compile this program or if you want to get the output from this particular program, you need to execute this program first, right? So in Java also, when I write a Java program, until unless we execute that program, we will not get the output, right? So who is running that program? Who is giving this output? Internally, there are compilers. debuggers, or interpreters. So these are the programming softwares internally we have. So those are responsible for compiling or debugging or interpreting our code. So interpreting and debugging means each and every statement will go through. That is debugging. Compiler means it will check all the statement at once and throw whatever errors we have. On interpreter means it will check line by line. If I find any issue in the particular line, it will throw that message or error message. So that particular job is done by the programming software. Compilers, debuggers, or interpreters, which comes under the programming software. And then application software. So application software is exactly the software which we are using in the online or somewhere else. So industrial automation, business software, games, telecoms, all these are examples for application software. All financial applications or internet banking application or portal, social sites, whatever we are using online, so everything will comes under the application software. Application software. So if you want to develop the application software, we require system software, and then we also require programming software. So until unless we have system software and programming software, we cannot develop application software. Okay, so these are the three different types of softwares available in the market. System software, which are responsible for running your system, and programming software, which is responsible for executing or compiling or debugging, interpreting your programming code, and then application software used by the users. Okay, any application if you take online, which comes under the application software. Okay, so we are going to test most of the application softwares, not programming or system softwares. Right. So usually the system software, programming software, we cannot directly use it. But internally at the hardware level, they use it. They use these three softwares. We cannot test directly those softwares. So application software we can see and we can interact, we can do certain operations and transactions. So all kinds of testings we can perform on the application software. Okay. So these are the different types of software. System software, programming software, and then application software. Now let us move on. So in the industry we heard about two different terms, product and the project. So what is product and what is project? Product is an application which is developed for specific customer. So that is basically called as a product. So if a software application is developed for multiple customers requirement, then it's called as a product. And if the software application is developed for specific customer requirement, then it is called a customer project. So let me explain this. This is also called as an application, project and product. So a very simple example. For example, we have a IT company. So there are multiple clients we have. Suppose, for example, suppose X bank and Y bank and Z bank. There are n number of banks are there. So suppose the bank X is approached the company and the company decided to develop a software for this particular bank. So that is basically called as a project. Okay, so they take up that project, they have completed within the timeline and they deliver the software to the customer X. That is done. And this particular project is only for specific customer. So that's the reason we have called as a project. Okay, certain number of people will be allocated and there will be some timeline and they'll complete this project within the timeline and then deliver the project to the customer. So that comes under the project. And the same project cannot be used by some other customers. Okay, this is only specific to that particular customer. So that is a project. And product is not like that. So the product will satisfy multiple customer requirements. Okay, for example, let us say MS Office, MS Word, Excel, PowerPoint we are using in your system, right? So they are products from the Microsoft. So those products can be used by any customer. Anyone can install and you can use it, right? So that is implemented or developed for multiple customers. Certain like Windows operating system used by multiple customers. That is not for specific client, right? So these are all comes under the products. Product is nothing but a software which is developed only for multiple customers, whereas a project is an application which is developed for specific customer, which is specific customer. So that's the difference between product and project. You can say simple. Project means stitching clothes and product means a ready-made clothes. This is a simple real-time example we can say. Okay, so these clothes can be purchased by anyone, but the stitching clothes can be taken by only one person, right? So this is specific to project. This is multiple customers, specific to market requirement. In other words, we can say based upon the market requirement, they will develop the application. So there comes under the product. But project is not like that. Project is developed based on the customer requirement or specific customer requirement. Okay, so that's the difference between product and project. So these are the basic things which we need to understand before going to the testing. Right, so now let us come to this testing part. So what we discussed so far is what is software testing, what are the types of testing. We have discussed about system software, programming software and application software, and then we discussed about the product and project. Now what is testing? So where the testing come into the picture? So testing is basically a part of software development process. So what are the different process, what are the different phases we have? So any product, if you want to develop, we need to go certain process. So any company, not only IT company, it can be any medical company or financial company, any industries, if they want to produce certain output, they should follow certain process, right? There are some phases. So ultimately, finally, we will get the ultimate product. So here the software testing is one of the phase in throughout development process. So for example, development process will start from understanding requirement and the designing part. So once the design is there, coding is completed by the development and then testing comes into the picture. After that, we will release the code to the development or we can maintain that particular code. So these are the different phases which we need to follow. So here where the testing come into the picture, testing is one of the phase. Throughout the development process, testing is one of the phase. So once the understanding, designing and coding, everything is completed, we will test the software according to customer requirement. So before releasing the software to the customer, you are checking whether the software is working according to the customer requirement or not. Is there any defects or not? So that we need to make sure. So that is all about the testing. So software testing is a part of software development process. So this is one part of entire development process. Okay, and this is one of the phase. And software testing is an activity to detect and identify the defects in the software. So in other words, we can say it is an activity or this is an action what we are going to do as part of software testing. So testing is one of the phase, But during this phase, what we are going to do? We are testing the software. So what is the purpose of testing the software? So to identify the defects in the software. So to detect and identify the defects in the software. So that is the main activity which we are going to do as part of the testing. And the main objective testing is to release quality product to the client. So this is the goal of the testing. The main objective of the testing is to produce a quality product to the customer. So customer should not have any issues. So before that, we need to test software thoroughly according to the customer requirement, and it should not have any defects. We need to make sure, and then everything is fine. Then we deliver the software to the customer. So this is the main purpose of the testing. So testing is a part of the development process. It is one of the phase, and the testing is basically an activity to identify the defects of the software, to identify defects, find the defects, the software, and then the main objective of the testing is to produce the quality product to the client. Quality product. So here we will discuss about what is quality, how we need to measure the quality of the product. Right? So testing is nothing but a quality. Why we need to do testing is to produce the quality product. So if you come to the testing, why do we need to test? What is the main purpose of testing? So for example, let us say a scenario, as a customer, as a user, so I want to purchase a mobile. Okay, so I have certain budget. I expected some features to be there in the mobile phone. Right, as a user, I want to purchase a mobile. I have certain budget, and I have expected some features to be there in the mobile phone. So what I will do, I will analyze multiple mobile phones in the market, all different brands and their features and the price, everything I'll do and analyze, and then what I'll do finally, I'll purchase a phone which comes under my budget and which will satisfy all my features, right? So once we get this phone, once we started using it, suppose if some features are not working according to my expectation, what happens? We'll start frustrating with it because we spend a lot of budget on this, right? So the same thing will happen in your software industry. So once we have developed the software, once we deliver the customer, if customer started using it, if they find more number of defects while using or the production systems, then they will come back and they'll start frustrating with this. So to avoid this, we need to test the software before delivering to the customer. So why we need to do software testing is ensure that software is bug free. Software should not have any defects. That's the first thing. And to ensure that systems meet customer requirements and software specification. So this is another main objective. It should meet our customer requirements. So customer says something, we developed something else, but there is no use of it, right? So whatever the customer is asked, whatever customer is expected, so those features should be part of the software. So that is the meaning of system meets customer requirements and software requirements. So requirements usually given by the customer. So customer, whatever he is expecting, that should be part of the application. So then only the customer will satisfy. So that's the main thing. Ensure that system meets end user expectations. So whatever he is expecting at the UI level or transactional level, everything whatever he is expecting, that should be satisfied. So that is the main objective testing. And fixing the bugs identified after release is expensive. So why we need to do all these things? Because If we get any bugs after releasing the product to the customer, so that will be very costly. Okay, because why it is very costly? Because the recycle happen. So again he will come back, again we need to analyze the defect, we need to implement, and again we need to test it, and then we need to throw out the customer. So again these activities again we need to perform again and again. So the lot of time and also lot of budget is required. That is more expensive after releasing the product. So that is the reason we need to perform a set testing. So to ensure software is bug free and our software should meet system requirements or software specifications which is provided by the customer, and to ensure that system meets our end user requirements. End user requirements. End user is nothing but a customer. And fixing the bugs identified after release is very expensive. That's the reason before itself we will spend lot of time on the testing. When you compare to the development or designing other activities, testing is having more time because testing is very sensitive. So we need to test each and everything thoroughly, all the corner cases and everything, to make sure we are producing the quality product to the customer. Right? So that's the why we need to do the testing. Now we are saying about the quality, right? The main objective of the software testing is to produce the quality product to the customer. So in what cases we are saying we are delivering the quality software? On what basis we say, suppose we develop a software, right? So we are saying this software is very quality software. So how we will say, on what basis, what is the criteria we need to consider? So if you want to say software is a quality product, then we need to consider these particular points like bug free, delivered on time. With not only one criteria, we need to have multiple factors or multiple criteria. So based on this, we need to decide our software is quality or not. Not only single parameter. So we have multiple parameters. So now let us discuss here. Quality is defined as a justification of all the requirements of the customer in a product. So who will say the quality product is quality or not? So whoever is purchased the software, whoever is using, so that is a guy is responsible for telling the whether the product is quality or not, right? So that is a justification which is provided by the customer basically. But on what basis they will provide the justification? So they have to keep in mind these points. So quality software basically should be bug free. It should not have any bugs. That's the one criteria. Not only that, the software should deliver on time. So for example, customer is allocated some budget for 3 months, right? So the software development, testing and all these things is taking more than 3 months. So it is crossed our delivery time. So again, he has to spend some other budget, some more money on the project. So that is not feasible. So delivered on time. So whatever time we have committed to the customers, on that particular time we need to deliver the software. So that is also one of the parameters to consider the product quality. And then within the budget. So suppose the customer is allocated some budget. If you are developing or testing the software more than this budget, suppose number of people or number of hardware resources, so software licenses we purchased, all these things taken more money when you customer is spent budget, so it is crossed the particular budget. So then is also you cannot say that is quality product, because the customer whatever budget they have spent, whatever time they have spent, whatever time they have given, within the time frame, within the budget, we should be able to develop the software. So that's the main criteria. Otherwise, what happens? The timelines will be crossed and it will be delayed to the customer. At the same time, they have to pay extra money to the vendors or IT companies. So because of that reason, we need to also consider these criteria. So delivery on time, and it should be within the budget, and it should meet the requirements or expectation from the customer, and it should be maintainable. So what is a maintainable? Once we release the software in their environment, if they install the software, so if there is any small bugs or occurred, we should able to immediately fix it, or we have to maintain the software in the long run. So that is all about the maintainable. So these are the main important points which we need to consider before telling the quality product. If you want to say a product is quality, that particular product or software should meet all these criteria. Okay, then we can call as a product is a software quality. It should be bug free, it should be delivered on time, and it should be within the budget, and it should meet the requirement or expectation, and it should be maintainable. Okay, so this is all about the quality. So quality is basically the justification of the customer. So customer should say whether the product is quality or not. So as a tester, we can say somehow, but it is not 100%. Because if we don't have any bugs in the software, everything is well, then we can say our software or product is a quality. But actually, when we will say exact quality, once the customer is started using it, if we don't find any issues, and then we can say exact quality, 100%, the product is quality product, right? And then, so while testing the software, we need to know these terms: error, bug, and failure. Okay, so as a testing, you will execute your test cases, you will test the software according to the customer requirement, right? So there are two terminologies which you need to understand. Error is different, defect or bug is different, failure is different. So people are using these three terms very frequently in a IT environment. So error is different, defect or bug is different, and then failure is different. So what is error? Error is basically related to the programming. Error is basically related to the programming. So any incorrect human action that produces a problem in the system is called an error. So who is causing this particular error? Human is causing this error. Suppose the developer written some program, right? So he did some mistake in the program. It is not giving expected output. So who is responsible for that? So the developer is responsible for that. What is the causing to get that particular issue? The main thing is they have done some mistake in the program. So that's the reason that is causing an error. So the error is an incorrect human action. An error is an incorrect human action that produces a problem. So because of this error, it is giving some issue or it is giving some problem. So that is basically called as an error. In the system is called an error. Again, here we can call logical errors, syntax errors. They are related to the programming. And there is another kind of thing, defect or bug. In the testing perspective, if you find any mismatched functionality, like according to the customer requirement or according to the expectation and actual result, if both are different, then we can call as a defect or bug. So this is the testing point of view. We are calling as a defect or bug. Okay, so this is deviation from the expected behavior to the actual behavior. So actual behavior and expected behavior. So these are the two important things. Expected behavior and actual behavior. So how we will expect this behavior according to the customer requirement. So whatever requirement says, the software or application should work exactly the same way. That is expected behavior. But if our application is working differently or not expected, then there is a deviation. So that deviation we can call as a defect or a bug. Defect or a bug. Right? So the other one is a failure. The deviation identified by the end user while using the system is called as failure. So failure is happen always in the customer environment or in the production environment. So once we have installed software to the customer environment, they started using it and then they found some mismatch or some application or product is not working according to their expectation, and there we can call as a failure. Okay, so these are the three terms which we need to use in three different places on three different situations. So error is belongs to the programming. Any human incorrect action, that is basically called as error, that is causing by the user. And defect and bug. So defect is bug is basically deviation from the expected and actual result in the application. Then failure should happen at the customer side at the production level. So if something is goes wrong in the production, so that situation we call as a failure. So certain failure happen in the production. Okay, we need to use these terms so very carefully. So based upon the situation and the criteria. Error, defect or bug. As a tester, we always talk about the defect or bug. So some people will use defect, some people will use bug, and some people also will use some issue. Okay, or some people also call as a CR. So customer request. CR is nothing but customer request. So these are the different terms which we need to understand. So before going to the testing. So now you understand what is the difference between error, defect or bug or failure. Yes. So if you are clear, just please say yes or no in the chart window, then I'll proceed. Okay. Great. So error is an incorrect human action, or defect or bug is a deviation from our expected and the actual, and failure should happen at the production level. Once the customer is started using the product, if you find any system is not working according to his requirements or his expectations, then we can call as a failure. Right? So why there are bugs in the software? So usually we are talking about bugs and we are talking about software. So why should the software should have bugs, or why should software is having some defects? There are many number of reasons. There are n number of reasons, but these are the 5 common reasons. Every software should have bugs because of these 5 common reasons. Not only these 5, there are n number of reasons are there, but these are the 5 common reasons which will fall under this category. So miscommunication or no communication. So software development is nothing but there are n number of people will be involved during the process, and they have to communicate exactly the same way as per the requirements. And if there is any miscommunication or there is no communication, then it will lead to the errors or it leads to the defect. Suppose product manager is saying something and developer is developed something else, and developer is understood in different way, or tester is understood in different way, so that will not work, right? So miscommunication or no communication will leads to the bugs in a software. That's the one major reason, because n number of people or multiple people or multiple roles people will working under the software. In software complexity, sometimes complexity means it's a huge project. So it is going as a years of project, and there are n number of modules are there, huge number of modules, and there are n number of people are working n number of modules, and project is very complex. So developing individual components and then integrating those components. So all these things will take a lot of time and effort and n number of people working on the project. So because of this complexity also, we may miss something in the software. That is common thing. And programming errors. Suppose developer is not created certain correct program, programming not certain way, then in later point of time that will be caused for getting the issues in the application. So that means root cause is developer is not developed properly. Okay, so for example, let us say some example. There is a particular screen, we are entering some data here. Okay, suppose if I want to enter some invalid data, it should throw some error. It should throw some error. Or suppose it is accepting the invalid data. So what does that mean? This is not our expected behavior. So where is that root cause happens? So root cause is there in the program. So while developer is writing a program, so whatever details we are entering here, he has created or he has written that code such a way that everything is accepted. He is not put in any validation points here. So whether the data is correctly entered or not, that we need to verify first, and then we'll process the data in the database. So he's not verified that data. As is, when we submit the data, he processes the data into the database. So that is not our expected. So where in the application side we will understand this. We can observe this behavior. But where that exact mistake is happened at the programming level. If he is not fixed here, that never fix here. Okay, if anything comes in the application, that is because of the programming error. So that is one of the big cause for software is having the bugs, programming errors, and changing requirements. So this is common thing in software industry. Every time the requirements will be changed. Every time the requirements will be changed. So for example, today customer says one requirement, tomorrow comes and says one more requirement, or they can ask you to change the existing requirement. By the time you already implemented the software, again that is little bit difficult to change or modify your existing one. Right? That is another challenging thing we will face in the software industry. Because of that reason, agile model comes into the picture. So in agile process, we can accommodate all the customer requirements whenever he say the new requirement or whenever he says some changes in the existing requirements. Everything can be accommodated in your software. So based upon the agile process. So that we will discuss it later. So changing requirements is one of the reason which will cause the defects in the software. And the lack of skilled testers. Suppose the testers doesn't have proper skill, they may miss some issues or they may not test something, and that will be causing the errors in the, or that will be causing the defects in the production environment. So that's another reason. Okay, so these are the major 5 reasons which we need to consider. Because of these reasons, so the software have bugs. Software is having bugs. Okay, miscommunication or no communication, and complexity of the software, and then errors in the programming which we have developed by the developers, and frequently changing requirements by the customer, and then there is no proper skills for the testers. So these are the main reasons the software should have bugs. So now let us move on. Let us talk about SDLC. So far what we have discussed about the basic things. What is testing? Okay, what are the difference? What is software? What are the different type of softwares? And then what is the quality? And what is software testing? And why we need to do testing? So all these things we have discussed at the beginner level. So now, before going to the actual testing, before understanding the testing concepts, we need to understand a basic history of the software testing. Because why software testing is started in the industry. And okay, so before testing, what is the process they are followed in the company? All these things we need to understand as a tester. And in interview point of view also, this is more important. So let us discuss about software development life cycle, SDLC. So SDLC basically talk about the process. SDLC will talk about the process. Any company, if you want to deliver a product, what are all requirements they have? Let us say company. This particular company requires certain inputs, right? Certain inputs this required. Or we can say raw material. And within the company, they process multiple phases. And then finally, it will produce a product to the market. So any industry, if you're medical industry, they'll take some raw material and they will make some medicines, and finally they produce those medicines in the product. Similarly, IT company, they will take all the inputs and requirements for the customers, they develop the software and then deliver the software to the customer. So the development of the particular software should happen in multiple phases. And there are n number of people will work in different phases. So that is talk about the SDLC. So SDLC basically talks about the process, where we need to start development process and what are the different activities which we need to perform. What is the ultimate goal of it and what we will get after completion of the process. So all these things will talk by the SDLC, Software Development Lifecycle Process. Right, so now let us discuss what is SDLC and what are the different SDLC models we have. So we will discuss few legacy models like almost 10 years, 15 years back, how the industry was, what are the different models they were followed. And then we will discuss about the latest trend. So once we have understood what are the limitations and problems in the legacy models, then we can easily understand what are the advantages in the latest models. Okay. So in the previously, almost 15 or 20 years back, these are the models we have. Waterfall model, incremental model, spiral model, and V model. So Agile is the latest one. Agile model is the latest process or latest model which currently market trend is following. So before going to the Agile model, we need to know a little bit about the previous models, because if you want to understand the advantages of latest models, we need to understand the disadvantages in the legacy models. There is a prerequisite. So that's the reason we need to learn, we need to know basic things about the legacy models. What are the disadvantages? How the software process will happen. So let us discuss one by one. We have waterfall model. This is very old and the first model which came into the market whenever the IT industry started. At that time, waterfall model is started at the beginning level, and then incremental, spiral. After these three models, the V model came into the picture, and this is also there in the market for the long time, and after that it is also gone, then Agile model come into the picture. Now let us discuss one by one. Waterfall model. So waterfall model is nothing but water is flow from upside down, right? So the same sequence it is also followed. So there are multiple phases we have, like requirement analysis, system design, implementation, testing, development, maintenance. So all these are different phases in the waterfall model. So in this model, each and every activities happen one by one after the another. So let us discuss what is main advantage of this model and what is the disadvantages this model. So first let us discuss the advantages. The advantage of this model is every phase we have a clear requirement. Like requirement analysis, we have certain documents. Each and every phase we have a certain documents. So requirement analysis phase, we do collect all the requirements from the customer and we'll make those documentation. We will happen some reviews and then we'll move on to the system design phase. So what happens here? The output from the requirement analysis phase becomes the input for the system testing phase or system design phase. And then output of the system design phase becomes the input of the implementation phase. And each and every output from each phase, that becomes the input of the next phase. And each and every phase having a clear-cut documentation, very clear documentation. That is the main advantage. Okay, so every phase we have a clear documentation. So if you want to if you want to start implementation phase, we should depending on system design. So there should be some document. Based upon the document, we will proceed the further steps. So this is a sequential manner, and this is basically suitable for long-term project. At that time, around 20 or 30 years back, so this particular model is suitable for long-term projects, 2 years, 3 years, 5 years projects, because every phase having its clear requirements. Once the complete phase is completed, then only we can move forward to the other phase. So once the design phase is completed, then implementations will start. Once the implementation is completed, then testing will start. So this is the way of working waterfall model. So if you understand this, there are major drawbacks here. One is, if you observe here, suppose I have 30 people are working on the project. There are 6 phases we have. So here 5 people, here I have look 5 people, or 5 people here, or here 5 people. So I have allocated some 5 people in each and every phase. So here I have my project duration is 30 number of people. My project duration is 3 months. Okay, assume that. So then what happens here? Until unless the requirement is completed, these all peoples are free, right? So until unless the requirement is completed, these all, suppose let us say this particular phase is completed within 5 days or 6 days it is taken, all 6 days these people are free. So that means we are paid them, right? And also there are number of days or time is wasted here. That is a major advantages. So this is very costly. It is costly because we need to pay other things. So until unless we completed the one phase, we cannot proceed the another phase. So here the design engineers, depending on the requirement, and development or implementation phase, the developers will involve. So these developers are depending on design phase, and testers are depending on the implementation. Deployment is again depending on the testing. So this is purely dependency model. Everyone is depending on some other people. So this is the main problem. The other problem is also we have. So for example, the customer given some requirement and requirements are everything is freezed. Then we started design, implementation. Currently we are in the testing phase, for example. Now customer is came back and say, my requirement is changed. Okay. So then what happens? According to his requirement, again we need to go back and change the code. If you want to change the code, again we need to change the design. If you want to change the design, again we need to review the requirement. Again we need to go back and recheck verification again, and again we continue the same thing. So this is again problematic. Once we proceed further, again we come back is nothing but a very toughest task in the real time. So these are the two major challenges. So we cannot accommodate frequently changed requirements. In this model, we cannot accommodate frequently changes in the middle of the project. So that's the main issue. There are two issues. One is cost effective, because until unless the one phase is completed, the other people should remain free, and then there is budget will be wasted. And the other one is, if you find any issues in the later point of time, or if the customer came and says some changes in the requirement, then again it is a tedious task to go and recheck the previous phases. So these are the basically problems in the waterfall model. And then incremental model came into the picture. So incremental model, somehow it will overcome the problems in the waterfall model, but still it is having the same problem. So in waterfall model, there is one more problem. We have only one phase of testing here, right? What does that mean? If you find any issue in the testing, again we need to change code accordingly. Again we need to change the design, and again we need to refer the requirement. Because the testing is a one of the phase here. Once we crossed all the above phases, then testing is coming into the picture. So we have only one phase of testing here. Again, incremental and iterative model. So this particular model will solve a few problems from the one phase, SDLC phase, the waterfall model, but still it has some issues. So here the process is developed. The process is divided into multiple iteratives, like multiple incrementals. So for example, let us say here, customer is having 10 requirements. 10 requirements. He has given only first 3 to 4 requirements, for example. For those 3 requirements, we will start design, development, testing and implementation. So one process will go on few requirements. And later point of time, again he will come back, customer came back and given few more requirements. And then we have, for those requirements, again we start another cycle. Again it will go parallelly. So design, development, testing and implementation. And again customer came and again given 5 more requirements. Again we will start another cycle. So here the parallel cycles will go on. So because of this, what's an advantage? We can overcome 2 advantages, 2 problems which are there in the waterfall model. The first advantage is the people who are working, they cannot sit ideally, because there are multiple cycles are going on, right? So here the developers are busy, here the testers are busy, some other phase, the implementation phase, people are busy. So in any way or any phase, the people are engaged with the work, so they are not idle. So that is the one problem we can overcome. The other problem is we can accommodate new changes. So for example, they have given few requirements. In the waterfall model, the problem is until unless we get all the requirements, we cannot proceed that process. We should get everything. Customer have 10 requirements totally. All 10 requirements we should get, and then only we can start process. But in the second model, no need to wait for all the requirements. As soon as the customer given few requirements, we can start development by using those requirements. Suppose in future customer given few more requirements, we can start another process parallelly. So this is basically called as incremental model. So once everything is completed, implementation is completed here, we will integrate the product, final product. Here integration testing should happen, and then we deliver the software to the customer. Because all these features are there in a single product, single project. Okay, so that's the reason. So this is incremental or iterative model. So in this model also, we achieve something, some advantages, but still we have problem called testing. So we have only one phase of testing. So if you find any defects in the testing phase, again we need to go and change the code, design, requirement and everything. So that is another problem still remains or still persists in the incremental or iterative model. Right? So now let us move on. Another model came into the picture. Spiral model. So after incrementation model, there is another model came into the picture. So this is called as a spiral model. So basically this particular model is developed for products, not for the projects. So usually what is the behavior of the product? Product is having multiple versions, right? So for example, let us say Windows. Windows is started at the 98. Windows 98 is the initial version of Windows operating system. After that we have 2000 version. After that we have 2003. After that we have 2006. And then 2000 Windows 8 or Windows 10 and 2012. So there are multiple versions of Windows have been released into the market. Similarly, if I go for MS Office, MS Word, Excel, PowerPoint initial version is 98 and then 2000, 2005, 7, 10, 2012, 2016 is going on. Why they have released these many versions? Because based upon the market requirements. So market requirements keep on changing. What they have done is they have initially implemented one product and they have analyzed the market and then get the requirements and implemented those requirements and deliver the another version of the software, latest version. Similarly, the next version, so on. So it will keep on changing. They are keep on releasing the newer versions until unless the customer is expecting something. Right. So this is basically version. So this particular model will 100% will suitable for products, not for the projects. Okay, because the projects, why it is not suitable? Because the projects is a one-time job. So some customer will come and they will provide some requirements. We will develop the requirements, test the requirements, and then deliver the software to the customer. Our job is done. The only one cycle. But in the product, that is not like that. So products having multiple cycles. Initial version, we will understand the market requirements, develop the software, test the software, then release to the market. So version 1 is done. Now again get the requirement from the market, again the development, test it, and then release the next version to the market. So it is good, keep on going that. So there is no limit for that. Until we have requirement from the market, the product newer versions come into the market. So here the model is also work the same way. So if you observe this particular model here, this is a spiral. Why we call spiral is nothing but this is a circle. So first the red circle, if you observe, this is the one cycle representing the one cycle. So here requirement, design, construction means coding, testing and deployment. Deployment is nothing but deliver the software in the market. So for this red color, one cycle is completed. On top of the first version is released into the market. And then on top of the first version, again we do some market analysis, planning, requirement analysis, design, construction, testing, and deliver the next version. So here version number is released, here version 2 is released. And top of version number 2, yellow is started. That is another version. Again requirement, design, construction, testing, and deployment, and deliver the software into the market. So this cycle will keep on going like this. Keep on going like this. So whatever version they have released into the market, on top of the same version, they will implement few more features and deliver the software to the market. So this is how the spiral model will work. So this is especially for the products, not for the projects. Right? So now here also we have a same problem again, that is we have only one phase of testing. There is only one phase of testing. If you find any issues during the testing phase, again we need to recheck the previous phases. Now to overcome all these problems, V model came into the picture. V model came into the picture. So V model came into the picture only because of one reason. That is, in the earlier phases or legacy models, we have only one phase of testing. So if you find any issues during testing phase, we need to again recheck the earlier phases. Again we need to change the code. Again we need to change the design document. Again we need to refer the requirement. All these things we need to repeat. To avoid that, the V model came into the picture. So in the V model, so if you observe this particular diagram, you can understand. One side we call as a verification, on the other side we call as a validation. So here the development activities will be taken care, here testing activities will be taken care. So here the development and testing, so both are parallelly happens. How it will overcome the other phases problem means development as well as testing activities go parallel. Will go parallel. So for example, how it will go parallel. So here there is that is one thing, it will go parallel. The other thing is each and every phase we have a testing. So in earlier phases we have only one phase, that is testing phase, right? But here we have in each and every phase. For example, requirement phase we have a testing, and the design phase again we have a testing, coding phase we have a testing, and testing phase again we have a testing, and deployment phase we can have again testing. So each and every phase we will do some certain kind of testing. So that is the main advantage of V model. So what is the main advantage of that? So for example, if I do here, suppose the requirement phase we do the testing, design phase we do the testing, coding phase again we do the testing, and testing phase again we do the testing, and deployment phase we have again the testing. So what is the advantage of this? If you already do some testing on the requirement document, there is less number of chances to get the issues in the design phase, right? If I do the testing in the design phase, again there is less number of chances to get the issues in the coding phase. Again in the code itself they have done certain kind of testing, then there is less number of chances to get the errors in the testing phase. So what is the main problem here is to avoid the coming issues or in future issues in the earlier itself, before itself. So what will be the test during requirement phase? Yes, requirement phase we don't have any software, right? We have only the documents. So we do conduct certain testing on the requirement document. In in the form of reviews, walkthroughs, and inspections. So these are the testing techniques which we need to use during requirement testing. So here we have only documents. Even in the design phase, we have only documents. The exact software is not yet ready. But what we need to test here, we need to test the documents, whether it is correct or not. If it is correct, is it clear or not? Is it understandable or not? All the requirements are specified or not? So these things we need to test. So that is the requirement phase testing and design phase testing. So until unless the coding is done, our software is not yet ready. So during requirement phase and design phase, we will test only the documentations. Only the documentations to ensure the correctness and completeness of the document. So whether the documents are correct or not, the information they have provided is correct or not, and that requirement is completed or not, or something else is lacking or not. So these things we will test the documentation. So that is a part of the requirement and design part. Okay, we are going to discuss all these things. Okay, so this is a picture, say just high level. So as I said, each and every phase we have a testing. So requirement phase we do testing, design phase we do testing, coding phase we do testing, testing phase we do testing, and design deployment phase also we do the testing. But all these testings are not done by the single person or single team. So there are different teams are available. Okay, I'll tell you who will do what type of testings. We will discuss in detail. So this is a basically V model. So V is nothing but a verification. Another V is called as a validation. So here in the left side, all these phases comes under the development process. And here right side, all these phases comes under the testing, or this is QA. This is QA and this part is development. Both will do parallel. Now you understand. Coding phase, like as soon as the programming is done, coding is completed by the developer, we do unit testing. Unit testing is done by the developers. Remember this, unit testing is done by the developers. Basically the unit testing will focus on testing the programs. What they have created, they'll test those programs directly. That is unit testing. And here integration testing is done based upon the HLD and LLDC. High level document and low level design document. High level design document and low level design document. As I said, we have design phase testing, right? So requirement phase testing, these are two are the requirements. BRS means business requirement document or customer requirement document or user requirement document. Anything is fine, names are different. And software requirement document or software requirement specification. But what is the difference here is BRS, CRS and URS is given by the customers. That is not in the technical way. Generic way, the requirements will be noted down. But in SRS, the requirements are converted into technical perspective. So this document can be understandable by the developers, testers, all the project team. So here, during these above phases, we conduct review. Review is nothing but whether the document is correct or not. The information which is provided in the document is complete or not. So that we need to verify. That is also part of our testing. So now during requirement phase, this comes under the requirement phase and these two comes under the design phase. During requirement phase and design phase, we will conduct reviews on the documentation. Reviews on the documentation. But software is not yet ready yet. So software is not yet ready yet. So whatever documents we have, we will test those documents. Correctness and completeness. If the document is correct, then automatically whatever software we developed based on that document will be perfect. If some information is lacking in the document or some information is wrong in the document, obviously the software which have going to develop is becomes wrong. So that is the reason before developing the software we need to make sure the documentation is perfectly correct or not. So that is the main important thing. Okay. So this is a verification part. So requirement phase testing and design phase testing. And here is this side actual testing. So verification in the sense most of the times we do the testing on the documentation. And testing validation means most of the times we do the testing on the software. Like unit testing will conduct on the software programs. And integration testing is combining all multiple modules. Unit testing means testing the multiple programs, single program. That is unit testing. So once we integrated all the programs, we make it as one build, then we will perform the integration testing. And then system testing. Actual testers are involved during system testing. As I said, in the testing phase also we have a testing, right? So this is basically system testing. So here we will test entire software, entire application, end-to-end application with respect to customer requirement. Whether the application is satisfying or working according to the customer requirement or not. So that we are going to discuss about the system testing part. We are going to discuss each and everything in detail in the coming sessions. So this is at high level. Okay, so here we do black box testing. So system testing is a black box testing. And then user acceptance testing. So before delivering the software to the customer, again they perform their own testing, that is user acceptance testing. So here user acceptance testing and system testing, we don't see any program internally what they have written. So this comes under the black box testing. We don't know, we cannot visible what they have created inside. So just we need to test that application whether it is working according to customer requirement or not. So that's the reason we call as a black box testing. When you come to the unit testing and integration testing, so they will test the programs internally, what programs they will created. So those programs they will test directly. So that's the reason we call them as a white box testing. White box testing. So in the V model, testing as well as development tasks will go parallelly, and each and every phase we have testing phase. So that's the reason there is a less number of chances we will get the defects in the later phases. So this is the main motive is we need to find the defect as soon as possible. We should not wait till the testing phase. Before coming to the testing phase itself, at the coding level they can find the defects, and integration testing level they find the defects, and the requirement or design phase also they can find some defects. So that is how the process will be. So this is about the V model. So this V model solves a lot many problems. There are, because every phase we have a testing, and software or developers as well as testers will work parallelly. So most of the problems it is solved. But there is still one more issue still there, that is this particular model cannot accommodate frequently changed requirements. Frequently changed requirements. So customer came with a new requirement, or he has came and asked to change the existing requirement in the middle, so that we cannot accommodate here. So because of that reason, people were thought about like another model, that is agile model. So that is the latest trend IT companies are following. Okay. Now, is it clear so far, Deepa? So these are all classical models. So waterfall model, incremental model, spiral model, and V model. So these are the classical models which we have discussed so far. Now this is an agile model. So here just I will give a high level brief overview of agile model, but there are lot many things we need to understand in this. So I will take this agile model itself another session. It will take one complete session on agile model. So because this is already part of our curriculum. So I will discuss this again at the end of the session. So not today, but here I will give a high level overview on agile model. Okay, because this is the current trend model, we need to understand this very detailed level. So in agile model, the entire release process is divided into multiple things. For example, let us say customer says 100 requirements. He has given 2 months of time. Okay, what we will do is in the 2 months of frame, we will divide timelines into multiple pieces. So this is first called as a first iteration, second iteration, third iteration, fourth iteration. So first we will pick up 3 to 4 requirements. We will complete all the tasks like development, testing, delivering requirement analysis. Everything will complete within one phase and deliver those 3 requirements to the customer. Customer will start using it. One version software released into the market. And then on top of this product, we will start second iteration. Here again, we will pick up few more requirements. Again, they will implement, test, and deliver the software to the customer. And customer will get the latest version. Now again, on top of that, we will get few more requirements. Again, implement, test, do everything, all activities, and then release to the customer. And finally, at the last iteration, we will integrate all the requirements and deliver the final software. So this is at high level agile model. So here lot many things we can accommodate. One is even though customer changes requirements, we can accommodate here. Okay, even the not only first iteration, suppose we are in the second iteration. So customers came back and say there are some requirements changed in the first version. So that change we can accommodate in the second version itself. So that is possibility is there. And we can accommodate frequently changed requirements, and also we can accommodate new requirements whenever it is possible. And one more important thing is customer will not wait till we get the complete product, right? So if whatever we have completed that we deliver to the customer, he will start using it. He cannot wait till all the software. Suppose he gave 1 year project, he no need to wait till 1 year. Okay, within 1 month itself, we can deliver one piece of software. He can start using it. And if he needs some feedback, he will give. We will get the feedback from the first version and we can get that feedback and do the changes in the second version. So that way we can progress. There are less number of chances to get the issues here because in every cycle we do the testing again. All the activities will be done in each and every iteration like planning, requirement analysis, design, building. Building is nothing but a coding and testing. So every phase, every iteration we do all the activities and every 1 to 2 months we deliver the software to the customer and he no need to wait till the software is completed. That's the main advantage of agile model. Okay, so just understand over till this because there are so many things which we need to learn about this particular model. Okay, so this is just high level model, agile model. So the software development, testing, everything will happen very rapidly and customer no need to wait till get the requirement. So nowadays everyone is following this particular model. So for example, if we see in mobile, you will install apps, right? So every time you will get some updates on apps. So why we are getting those many updates? Because of agile model. So we'll get the market requirements, quickly they will implement and they will give one update. And then again they will implement new more requirements. Again they develop the software, again they will give you one more update. Why we are getting so many updates like this? Because they are delivering the entire software into multiple pieces or multiple updates. So because of agile model. So every company, every software company in the industry are following agile. Is it clear now? So these are all software development process models. Classical models, V model and agile model. Right? So now let us move on to the few more terms like in the industry we hear these terms very frequently. QA means quality assurance, QC means quality control, QE means quality engineering. So we need to understand these terms very thoroughly. QA, QC and QE. People were calling in previous days QA or QC, but nowadays people are calling QE teams. QE means quality engineering. So I'll tell you why people are calling QC and QE basically. The first basic thing is QA and QC. QEs came later. Okay, QEs came recent times, recent years. So let us understand first QA and QC, and then we'll understand what is QE. So quality assurance is basically process related. Means suppose if you want to deliver a software to the customer, we will define certain process, right? We need to follow the process. So QA is always talk about the process. Means what we need to follow, like where we need to start, requirements, what are the different activities we need to do as part of requirement, and what are the activities we need to perform as part of the design phase, and the coding phase, what are the things we need to follow, and testing phase, what are the different documentation we need to prepare. So all these things is talking by the QA, quality assurance. So this is process oriented. It will always talk about the process. Remember this. Here is always talk about the process. QC or QE is always talk about the product. So in any industry, in any IT industry, there are three things. Remember this very carefully. Any company industry, there are three things. These three are the pillars of software industry. One is, we call as a three P's. One is people, one is product, other one is process. These are the three important key areas which we need to focus on. Any software industry rely on these three things. Every software industry having people, every software industry will produce a product, and every software industry follows a certain process. So ultimately, if we want to deliver this product to the customer, what we need to have, we should have people and we should follow certain process. Why we should have people and process? Because we need to deliver or we need to develop a product and deliver the product to the customer. So because of product, there are people and there is a process. These two things are required. So here QA is basically talk about the process. Here, this is the area of QA. It will define the process. Okay, this is our process, you should follow this. So that is introduced by the QA. QA is basically talk about the process. QC or QE is exactly talk about the product. Whatever product we are developing, it is talk about the products, how we need to develop this product, and how many ways we need to conduct the testing, what are the tools we have to use. All these things will be conducted, all these things will be decided by the QC, quality control. QC is the actual testing of the software. Okay, software means again product here. So QA is talking about the process and QC is talking about the product, actual testing of the software. QA focuses on building in quality. QA focuses on building in quality. Very important. Building in quality means why we have defined this process, because ultimately we should get the quality product. So this process always, QA is always talking about the process. So why process is required? To deliver the quality product. That's the main goal. So that is building in quality. Focuses on building in quality. QA focuses on testing for quality. So there is a lot of difference between these two terms. Building in quality is different, testing for quality is different. Building in quality means if you want to produce the quality product, we should follow this process. And testing for quality is if we want to produce the product as a quality, we should do certain kind of testing. Okay, so this is the testing. Again, the testing, who will decide this testing? QA will decide the testing. What testings have to be conducted, that is designed by the QA. But what testings we have to perform, actual activity which is designed by the quality control. So basically QA is process, QC is the implementation. QA will define the process, QC will implement the process. Just like a government and the people. Government will put the rules and people will follow the rules. Similarly, QA will define the rules and process, and rest of the teams will follow the same process and rules. So that is the difference, basic difference between QA and QC. And QA is a preventive defects, QC is a detecting defects. Prevention means before coming the defect, we need to follow the process correctly. There is no chance to get the defect. So prevention. So prevention, right? Detection is nothing but suppose if there is any defects, we need to find out. Already defects are there, then we have to find out. That is the detecting. Prevention means should not have any defects. For that, whatever activities we have to do as a prerequisite, we should conduct them. So that is prevention, right? Even if you get some disease, prevention is different, detecting is different. Prevention means we need to take care of certain things. Then we can prevent the defects or preventing the diseases. So after disease come, after detecting it, we need to go for the treatment. Similarly, here the QA will talk about the prevention. In future, we should not get any issues. So that is possible only through correct process which we need to follow. So that is defined by the QA people, QA. So once the software is ready, if there are some issues, we need to detect them. So QC is basically talk about that. QC is a basically practical oriented, QA is a theoretical oriented. QC is detecting the defect. So QA is a process oriented, QC is a product oriented. Process means this we cannot see, just as a process. We should follow what are all things. That is talking about the process. Product oriented means we need to more focus on the product, whether the product is working according to customer requirement or not, product is having defects or not. So all these things, more focus on the product, that is QC. More focus on the process, that is QC. Sorry, that is QA. Okay, And QA for entire cycle, QC is for only testing part in SDLC. QC means QA means that is a process I am talking, right? Process in the sense requirement process, design process, development process, testing process, all these things having process. So QA is talk about entire SDLC from the beginning to end. Once we get the requirement from the customer till we deliver the software to the customer. All these activities are process defined by the QA. But QC is involved only in the testing phase. So because only in the testing phase we test the software according to the customer requirement. So there QC will come into the picture. Quality control is basically responsible for testing the product according to the customer requirement. So these are the differences between QA and QC. So the main important thing is QC, QA, quality assurance is talking about the process. QC, quality control is talking about the testing. Right? But why people are calling QE means nowadays people are also doing automation. They are engineering, quality engineering. Engineering means previously people are saying software engineer. Why they are calling software engineer? Because they are engineering. Engineering means developing something new things. So people are called as software engineers. Nowadays testers also engineering the code. They are writing the automation codes. So the developers are writing the code for developing the software, and testers also writing the code for testing the software. So both are writing the code. So that's the reason QC people also called as quality engineering. Quality engineering teams. QE team is nothing but the automation testers. So whoever is developing the code, both are developing the code. So developer is developing the code for software, and tester is also developing the code for testing the software. One is developing the code for developing the software, the other one is developing the code for testing software. Both are doing the same thing. So that's the reason these people are also called as quality engineers. Quality engineers. Okay, so that's the reason people have started using this name. Is it clear, Deepa? QA versus QE and QC and QE. So because these concepts are very much required, so before actually going to the testing. So these are the very basic fundamentals. So now let us move on to the next concept, verification and validation. So in the V model, we talk about verification and validation. So there are a difference between verification and the validation. So what is the difference? So in the V model, when I talk about the V model, this side called as verification, and this side we can also validation. This is validation, this is verification. There is small difference, I'll tell you. So as I said, in the V model, we have requirement phase review, requirement phase testing, design phase testing, coding phase testing phase also we have a testing, and implementation phase also we have a testing. So every phase we have a testing, right? So here verification means verification checks whether we are building the right system. We are building the right system. That means we haven't developed the system right. System is nothing but the software. So we haven't yet developed the software, but we have a documents in our hand. So here, before developing the software, we are checking our documents in the form of reviews, in the form of walkthroughs and inspections. So that is a comes under the verification part. Verification tells us, our verification focuses on whatever we are doing, that is correct or not. That is a verification. Very simple. Whatever doing is correct or not. That is verifications. For example, suppose I want to go from somewhere to somewhere. I want to start here. I want to go here. So this is my source and this is my destination. So there are n number of ways are there. So this is another way, it will go to some other destination. It will go to some other destination. So I am here now. I want to reach to destination. So what is verification here? I have started here, okay, and I have till came here. Okay, now I am here. After coming here, before coming here, what we need to do, whether I am going to in the correct path or not, that I need to check. Once I reach here, again I need to check whether I came in the right path or not. Okay, already I have traveled here. So whatever traveled till here, that is correct or not. And before traveling, whatever way I am traveling, that way is correct or not. There is there is a lot of difference here. One is, before starting my travel, I need to verify whatever path I am going to travel, that is correct or not. That I need to verify. That is verification. Once I travel, once I reach there, again I need to check whether whatever path I have traveled, that is correct or not. That is called as validation. That is validation. Okay, so the question is, so far a software verification specialist, they won't have a software to test, right? Yes. So verification is always focusing on reviews, walkthroughs and inspections. Only testing the project requirements or project documents, not the software. So as soon as the software is ready, we will start validation, not verification. Okay, so that's the difference. So verification. So again, test cases and test plans, we do the testing. That is verification. We will conduct reviews, walkthroughs, inspections on the test cases as well as test plans. So that is verification again. So test plan and test cases also document, right? They are documents. So simple, remember this. Whatever the testing we are conducting in the documents, that is verification. Okay, whatever testing we are conducting on the software, that is called as a validation. Simple. Okay, so whatever testings we are conducting on the documents, why we are testing document? Because the software is not yet ready. Once the software is ready, then we will do the testing on the software. So that is comes under the validation. Got my point? So this document says how the software will be. In future, how the software will be. That is the document says. Once the software is ready, then there is no point of document. Directly we can test the software according to this document. You got the difference, verification and validation. So that's the reason I'm giving this example. So I want to travel. So let me just a second. So let me clarify once again. So just see this example, you can clearly get this. So this is my path, okay? So there are number of ways we have like this. So I am here currently. So this is my source location. I want to reach my destination location. So now I should have some map here. So I want to go to the destination. This is my path, right? So here, where I'm here, what about, I think, I don't know the way. Still I haven't traveled. So I have some map here. Map in my hand, right? I haven't traveled yet, but I have a map which will describe my path. So now I will see the map first, right? My map is correctly there or not. My map is correctly showing the path or not. That I mean to verify first. So that is verification. This is verification. So now, while traveling in this path, every path, so this is verification part, whether my path is correct or not. So once we travel here, suppose I am in the middle now. Once we reach certain milestone, here again, what I will check, I already traveled this path by using this map. Map is nothing but a document. Remember this. Map is nothing but a document. Based upon this map or document, we already developed the software. Somehow the software is ready here. Somehow I already traveled based on the document. Now again we need to check here whether whatever I traveled this path is correctly I traveled or not, or am I going in the wrong direction or not. So that we need to verify. So this is validation. So here by this time the software is ready. Okay. So verification is always conducts on documents and validation is always conducts on software. And verification talks about we are following correct path or right. Path or right. Are we are building the right system or not. Validation talk about we are building the system right or not. By that time system is ready, already developed. So whatever we developed, that software is working according to the customer requirement or not. So that is talking about the validation. But verification is, are we going to develop the correct software or not? Suppose I have developed some piece. So are we developed this properly or not? Or another version. So are we developing system is right or not? That is step-by-step validation. That is verification. Are we going in the right path or not? That is verification. So the document says, the documents will direct you. So in the form of reviews, walkthroughs and inspections. We will conduct some reviews on the document. Review is nothing but whether the document is correct or not, correctness and completeness. To ensure correctness and completeness. All the details have been mentioned in the document or not. Can you hear me now? Okay. There is some problem in the internet issue, I guess. Is it fine now, right? Yes. So simply just remember this, verification is nothing but are we going in the right path or not? So that is verification. Validation means are we whatever build or whatever software we develop that is working according to customer requirement or not. So that is validation. So verification is always conducting on the documents in the form of reviews, walkthroughs and inspections. Validation will conducting on the software. So system testing is an example for validation. Reviews, walkthroughs and inspections all comes under the verification. And sometimes unit testing is also comes under the verification. Unit testing. But here also we have only programs. Not exactly the final software is not yet ready. So the programs testing these programs is also comes under the verification part. Okay. So now you understood what is the difference between verification and validation. Verification will talk about the testing the documentation and it will focus on are we going right path or not. Whatever path we are going, that is right or not. Validation means whatever we already developed, that is working according to customer requirement or not. So that's the small difference between verification and validation. Now let us understand. There are multiple terminologies are here. Here all are interrelated. You need to understood. Okay. So far we have discussed about verification and validation. Okay. Observe very carefully. This is verification and this is a validation. Right. So as I said, in the verification, we are testing the documentation. And in the validation, we are testing the software according to the customer requirement. Yes, the static testing means testing the documents. So documents is always static, right? Once you have created the document, that is static. So conducting reviews, walkthroughs and inspections on the document is called as a static testing. And testing conducting on the software by giving certain inputs and getting outputs, that is comes under the dynamic testing. So static testing is a verification technique, dynamic testing is a validation technique. Okay, why we are calling static testing? Because we are testing the documents here. We haven't yet have software. So documents always static. So that's the reason conducting reviews, walkthroughs and inspections on the documentation is called as a static testing. And testing the software dynamically by giving inputs and getting outputs, that is comes under the dynamic testing. So validation is a technique, or dynamic testing is a technique of the validation testing. These are the interrelated. Got my point? So let me summarize here. Verification, validation, right? So in the verification, yes, exactly. So integration testing and system testing, UAT testing, all this comes under the validation part. Okay. So here observe this. Verification we do only on the documentation. Validation we do only on the software. And verification, in the verification we will conduct reviews, walkthroughs and inspections. In the validation we conduct unit testing, integration testing, system testing, UAT testing. So these are all comes under the validation. And here verification we call them as a reviews, walkthroughs, inspections we call them as a static testing techniques. And here unit testing, integration, system testing, UAT testing called as a dynamic testing. Now it is clear. Okay. So these are all interrelated. Verification means reviews, walkthroughs and inspections on documentation. So this is static testing. Validation means testing the software. Unit testing, integration testing, system testing, unit testing. All this comes under the validation. So these are also called as a dynamic testing. Right, so now let us discuss in detail what is review. So review is conducting on the document to ensure correctness and completeness. So as soon as we have requirements, yes, unit testing is also kind of verification because we will test the code, right? So in that particular context, we call them as a okay, fine. Because as part of the verification VV phase, so VV model, in the VV model, let me go through VV model once. In the VV model, unit testing is conducted on the coding part. So coding is nothing but the programs are ready. That means somehow the software is ready. Coding is completed means software is ready. So we do unit testing on the particular coding. So we call them as a validation. Call them as a validation. Okay. So similarly, integration testing, system testing, all these testings will be conducting on the software coding. So that's the means these are comes under the validation section. So there is only two criteria. Software is ready or not. That we need to consider. If it is ready, then whatever testings we do, that is comes under the validation. If software is not yet ready, whatever documents still we have, if you conduct the testing on the documentation, that is comes under the verification. Okay. So unit testing is also a kind of validation testing. So right, so now let me move on to this review. So requirement reviews, design reviews, code reviews, test plan reviews, test cases reviews, all these kinds of reviews we can conduct. So as soon as we get the requirement, we will review the requirement, whether the information which is provided in the review is correct or not, and design. So as soon as the design is ready, so all the design documents are correct or not, complete or not, that we need to verify. Code reviews. We will do code reviews, developers. So once they have written the code, they will test all the syntactical errors or logical errors, exception handling is handled or not properly. All these things they will do the code review and test plan review. As a tester, we need to prepare our test plan, test cases and everything. We need to also review those documents. Review is also a kind of a test. Okay, simple, remember this. Testing a document is verification, testing the software is validation. Simple. Okay. This is all about the review. Review is a verification technique. Review is a comes under the verification because here all reviews are conducting on the documents. Okay. Now walkthrough. Walkthrough involves multiple people. So review, only one guy who is suppose somebody is given you one document, you alone is sitting and review the document. That is a review. Simple. And walkthrough means multiple people. So someone is created the document, he will explain the document, and some other guy is also, or some guy will go through or walk through each and everything he will read, and some of the team or other team people will listen those document, and whatever clarification they have, they will ask those questions and get them clarified. So this is basically a simple kind of a meeting, that is walkthrough. Okay, so inspections. Inspection is nothing but again, which is conducting on multiple people, but here inspection is a formal approach. It's not an informal. Walkthroughs and reviews we can do anytime wherever it is required. But inspection is not like that. It should be a formal. We need to invite the people, and three people are very important. One is called reader, second is writer, three is a moderator. So reader means author. So whoever has created the document, he will read all the document, and moderator means he is act as a moderator between the team people and the author, and writer means he is the responsible for writing the comments. So whatever comments our team is giving, so those comments will write down and get the clarified. So all these things will be done by the three people: reader, writer and moderator. So this is another kind of meeting called as inspection. Okay, this is the formal. So because of that reason, we need to invite the people in the formal way by sending the emails and all. Okay, so review, walkthrough and inspection. So these three are comes under verification and testing the documentation. Mainly focusing on testing the documentation. Okay. Now we are going to discuss about levels of testing. Unit testing, integration testing, system testing, and user acceptance testing. So these are the levels of testing. So let us discuss this in detail. Very simple. Unit testing. Unit testing means testing a single unit or a single component or single program. That is basically called as a unit testing. So developer will write a program. Okay, so he will test this program. He will give certain inputs and proper output is coming or not. So that is testing by the tester. So unit testing. Integration testing is, suppose there are multiple programs like this. They will integrate all the programs, combine them, and they will test the integrated software. The communication between these modules are properly happening or not. Sometimes the output of the first program will become input of the another program. And whatever output is given by the second program, that is input for the next program. So this communication should happen properly. So that is integration testing. System testing is nothing but once the coding everything is completed, they will integrate all the things and make one software application. This is the final product or final build, and that build is provided to the testing team, and testing team will perform the system testing. So it is whether it is working according to the customer requirement or not. So here we will execute all our test cases and everything and report the defects to the development team. That is system testing. And once our system testing is completed, and customer side people will perform the user acceptance testing, whether this our software is working according to their requirement or not. In their environment, they will test it. So that is user acceptance testing. If you observe here, yes, integration testing and unit testing is always done by the developer. Okay, I'll talk about this in detail. Just please hold on for a few seconds. Okay. So unit testing and integration testing, system testing and user acceptance testing. Here, unit testing and integration testing always deal with the code. So that's the reason it is always done by the developers. And system testing is always, we don't know the code what they have internally created. So here we need to focusing on the test cases or test requirement, whether the system or entire application working according to the customer requirement or not. That we are going to test it. So here the system testing is done by the testers. Okay. And user acceptance testing is done by the users or customers at their environment. So that is user acceptance testing. So here unit testing and integration testing is done on the code. So they are called as a white box testing techniques. These two are comes under the white box testing techniques. And system testing and user acceptance testing comes under the black box testing techniques, because we don't know internally what they have written. We don't know the programming skills here. We don't know the programs. So whether this software is working according to the customer requirement or not. So that's the reason we are testing here. So that is black box testing technique. So these are the levels of testings. Now let us go individually one by one. So unit test means testing individual components, means individual component or individual program or individual a module, and the coding perspective. So that is unit testing. So it is done by the developer. And integration testing. So testing component groups or testing combining, after combining all the programs or after combining all the modules, we conduct integration testing. That is also done by the developers. And system testing, test the integrated system. So once we have integrated all the modules, all the programs, and they make as a final product or final software. So that software we need to test according to the customer requirement. So that is system testing. And then acceptance testing. So test final system. This is also testing the final system. But here the testing is conducted by the users or customers in their environment. Okay, that is acceptance testing. Unit testing, integration testing, system testing, and acceptance testing. So these are the levels of testing. Level means one after the another. So first unit testing come into the picture, and then integration testing, then system testing, and then acceptance testing. So this is one after another. So that is a levels of testing. Now let us talk about individual one by one. Unit testing. Unit testing is the smaller testable part of the software. It is usually has one of the few inputs and usually single output. So unit testing is nothing but a single program or single component or single unit. So this particular unit we will give some input whether we are getting proper output or not. That we need to test. So unit testing conducts on the single program or single model. Unit testing is a white box testing technique. Why it is a white box testing technique? Because we are testing the internal logic of the program. Directly code or program we are testing here. So that's the reason we are calling as a white box. White box means we can see whatever there inside. Unit testing is conducted by the developers. And they will use certain techniques for conducting unit testing. So basis path testing, control structure testing, again conditional coverage, loops coverage, mutation testing. These are the different techniques the developers will use to conduct unit testing. Okay, so this is all programming related. We no need to focus more on this unit testing techniques because we are not going to conduct the unit testing or integration testings. Okay, we are more focusing on the system testing. So now these are the unit testing techniques. So unit testing is a component level testing or module level testing or program level testing, and this is the white box testing techniques which is conducted by the developer, and he will use certain techniques to conduct unit testing. Okay. Now integration testing. Integration testing, as we discussed, it is conducting on integrated modules, and the communication between these modules are happening properly or not, that we need to focus on. And this is again part of the white box testing, because internal code again we need to test it. So this is conducted by the again developers, and he will use certain approaches to conduct the white box or to conduct the integration testing. So let me explain these approaches here. So for example, so entire software is divided into multiple modules at the time of development. So for example, I have a main module. This module is again pieces into module 1 or module 2 or module 3, multiple modules. Again this module is subdivided into another module. Suppose X is another module, Y is another module, A is another module, or B is another module. So this is where they will divide into multiple pieces. And now each and every module assigned to the particular developers. So now how integration testing will happen? Suppose if you combine these two modules, it comes as a one module. And if I combine A and B, that will becomes one module. If I combine all these modules, that will become one module. This is a main module, right? So here in integration testing, they will follow certain approaches. Top-down approach, bottom approach, sandwich approach. So what are those approaches? Let us understand. Suppose suppose in integration, first these two modules are implemented. Okay, and this module are also ready. So this module is already implemented. These two modules also implemented. So in the top-down approach, this is top-down approach. First high-level module is implemented and lower modules are implemented. So in the top module is already implemented and bottom two modules are already implemented. But this module is not yet ready. This module is not yet ready. But still I want to test all these modules integration. How we can test it? But there is this particular module is not yet implemented. In the middle, there is a module should be required if you want to test this integration, but this module is not yet implemented. But how we can perform the testing here? In the top-down approach, if any sub-module is not yet implemented, instead of these modules, we will write a temporary program. This program will act as a sub-module. And this is basically called as stubs. This is basically called as a stubs. Stub is nothing but a temporary program which will assist you instead of a main module. So this particular temporary program will integrate all these modules. Okay. So in top-down approach, if any sub-module is not yet implemented, to test the integration, we will introduce a simple program or a temporary program that is called as a stub. Stub is a temporary program which is used instead of using the sub-module in top-down approach. That is stub. And in the bottom-up approach, some people will start from the bottom to up. So first implement the sub-module and then implement the main module. In the bottom-up approach, these sub-modules are ready and this main module is also ready, but this module is not yet ready. But if you want to test this full integration, I require this sub-module. So instead of this sub-module, again I will create some temporary program which will assist instead of, this is a workaround for this particular module. So how this module will work in a similar way, this program is also work, but it is temporarily. Okay, so this is basically called as a driver. So driver is again a temporary program which we can assist instead of temporary. If any main module is not yet implemented, instead of this main module, we will write a temporary program that is called as a driver. So approach is different. So driver and stub both are same, but the approach in top-down approach we call as a stub. In bottom-up approach we call as a driver. Okay. Some people will follow combination top-down approach and bottom-up approach. One side they will start top-down and some people will start bottom-up approach. That is called as a sandwich approach or also called as a hybrid approach. Okay, so now let us see in detail. So driver stub is called as a module under test. So if any sub-module is not yet developed, instead of that sub-module, we will use some temporary program to assist that integration testing. That is called as a stub. Driver causes the module to be tested. That means any main module is not ready yet, and if you want to perform the integration testing, instead of that main module, we use a temporary program that is called as a driver. Now you see this diagram, then you can understand. So here we have multiple modules in bottom-up approach. Suppose module 1 is ready, 4 and 5 is also ready, but 2 is not yet ready. So in this module 2, we will write a certain temporary program. This is called as a stub. This is called as a stub. Now we will test this integration of all these modules. These modules integration we can test it. This is bottom-up integration. Now in the top-down integration, again we have these same modules. Top-down integration, again here these two modules are ready, this main module is also ready, but this module is not yet ready. Instead of this sub-module, we will write driver program. Okay, in the top-down approach we call as a stub. In bottom-up approach we call as a driver. Sorry, here this is bottom-up approach, so this is called as a driver. In top-down approach we call as a stub. This is a stub. Any submodule, we are coming from top to bottom, right? In the top to bottom, if any submodule is not yet ready, instead of that submodule, we are creating some program, temporary program, is called as a stub. So this will assist instead of the submodule 2. Now we can perform the integration test. So this is top-down approach. So stub as well as driver, both are exactly the same. The only theoretical difference, there is no practical difference. But in bottom-up approach, we call as a stub, we call as a driver. In top-down approach, we call as a driver. Is it clear? So this is integration testing, and these techniques are followed by the developers. We are not going to focus more on this. Just for understanding, we need to know these things. Okay. So bottom-up approach and top-down approach in integration testing. Now system testing. So this is the main area which we need to focus more, because we are all concerned with the system testers. So testing overall functionality of the application with respect to client requirement. Testing overall functionality of the application with respect to client requirements. Here we don't know internal logic, what they have created, what developers have been implemented, but we need to test overall functionality of that application with respect to the customer requirement. We have customer requirements and we have a software. So we need to test this software according to this customer requirement, whether it is satisfying customer requirement or not. And this is a black box testing technique. Why we are calling black box? Because we don't know what the developer has written internally. So that's the reason, completely hidden. So completely it is black box. So we call as a black box testing technique. And this testing is conducted by the testing team. Testing team is conducting the system testing. So before conducting system testing, we should know the requirement. That is the input of the document, right? We don't know how the developers have been done, but how we know, how we need to test the software. If you know the requirement, then we can test the software. So we should know before the requirement. Before testing the software, we need to know the requirement. What the functionalities are there, how the flows will be, what is the UI, so what are the different elements or objects are present in the screen, what are the navigations. All these things we should be aware of before conducting the testing. But all these things are available under requirement specification document, right? So as part of the system testing, as a tester, we are going to perform so many types of testings. So these are the high level categories: user interface testing, functional testing, non-functional testing, usability testing. All these testings we are going to conduct as part of system testing. Okay, so again, each and every category there are n number of testings are there. Even functional testing, non-functional testing, usability testing. This is at high level category. It is high level category. But internally, every type of testing having different kinds of testing. Okay, so let us say for functional testing, if I take functional testing, it contains multiple testings like object behavioral testing, input domain testing, exceptions testing, cookies testing, links testing, database testing. Okay, there are n number of testings again we have. Again, if you come to the non-functional testing, performance testing, load testing, stress testing, security testing, compatibility testing, installation testing, there are n number of testings are there. So as a system testing, as a system tester, we are going to discuss all these type of testing in the coming sessions. Okay, system testing. Now the last phase is user acceptance testing. So this is the last level. So for what are the levels of testing we discussed? Unit testing, integration testing, and system testing. So this is the user acceptance testing. So this is a testing is conducted after completion of system testing. After completion of system testing, and this testing is conducted at the two levels, alpha testing and beta testing. Alpha testing and beta testing. So basically alpha testing and beta testing is usually conducted by the customers or users at their environment. The small difference we have. So in alpha testing, we will test this application with some dummy data in their environment, and beta testing, we'll test that application with real-time data. Okay, so there's no small difference between alpha testing and beta testing. Both are conducted at the customer environment, right? So these are all levels of testing. So these are all levels of testing: unit testing, integration testing, system testing, and user acceptance testing. So as a tester, we need to more focusing on system testing. Is it clear, Deepa? So far. So now let us see methodologies, and then we will finish it off. So far we have discussed white box testing, black box testing. So what I said, white box testing means we don't know what is their internal logic. So testing the programs directly, checking the logic, that is comes under the white box testing. Black box testing, in a sense, we don't know what is the logic inside the programmer is implemented, but we test the software according to the customer requirement, whether it is working according to the customer requirement or not. So that is black box testing. So gray box testing is combination of white box as well as black box. It's a combination. So for example, if I say here, see white box testing first. So unit testing, integration testing comes under the white box testing. So internal code, what they have written, that we need to understand. We will provide some input and we'll get some output. So that is unit testing. Here the programming skills are required. When you come to the integration testing or black box testing, so completely black box. We don't know internally what they have written, but here we will provide some input and we will get some output. With respect to a customer requirement, it is working or not. That we need to verify. So that is system testing and UAT testing. So these are comes under the black box testing. So these already we discussed. Now gray box testing. So gray box testing is the combination of black box as well as a white box. So database testing is an example of the gray box testing. So why database comes into the gray box testing? Because let me give you one scenario here. I have a registration form in the UI. I need to enter all these details. Okay. So as a user, I want to test this. I want to test this scenario. How we need to test this scenario? I'll enter all the details and then I'll submit this button and then I will get some acknowledgement. So your information or your details are submitted successfully. So that is a one testing. So this is a UI testing. This is not complete testing. This is the UI testing. How we will make sure whether really this data is stored in the backend or not. There is a database. In the database, there are some tables. Let us say here there is a registration table. So whatever data we send through application, that data should be stored in the tables, in the database. But as a user, as a tester, I don't know whether this data is exactly stored in the database or not. Sometimes by mistake, the acknowledgement is also coming as our expected. But this is not 100% it will not give 100% assurance whether this data is stored in the database or not. Then what we should do? We should go and log into the database, and then we need to provide certain query. Let us select the star from registration. If I give query like this, it will give you all the records which are there in the table. Now, if I see this particular data, whatever record we have entered from the client or application, if that particular record is present in this particular table, then this is 100% testing, right? So here we are doing, this is basically black box, and here we are logging to the database and we are writing the query and checking the record availability. That is comes under the white box. So here we are using combination of black box as well as white box. So this is called as a gray box testing. This is a combination of black box and white box, comes under the gray box testing. Because why we are calling here white box? Because we are writing the query here and checking the record whether it is there in the table or not. So that comes under the white box. Is it clear now? So white box testing, black box testing, and then gray box testing. Okay. So these are all about the different techniques. So far what we have discussed, let me summarize. So we have discussed about what is software, right? And also we have discussed about what are the different types of softwares. Okay, types of softwares. And we have discussed about what is software testing. And we have also discussed about why testing is required. And we have also discussed about QA versus QE. And we have discussed about SDLC models. And we have discussed about V model in detail. And we have discussed about verification versus validation, right? And we have discussed about reviews, walkthroughs, and then we have discussed about inspections and static testing, dynamic testing techniques, and we have discussed about white box testing and black box testing and gray box testing. And we also discussed about levels of testing. In detail, we discussed about unit testing. Unit testing we discussed, and integration testing we discussed, and we discussed system testing. This is the area which we need to more focusing on, and we discussed about the UAT testing, alpha testing and beta testing. Okay. So these are the topics we have discussed so far. Any questions?